Okay, guys, last push. We are almost done. This is your semester 2 final exam review. Let's get right to it. Number 1, find n. Now remember, n is sides. One interior and one exterior angle of measure for a hexagon. Well, a hexagon has 6 sides. So cool. I have already found my n. I'll put a box around that. To find an interior angle, I'm going to have to use my SOY equation, which is n minus 2 times 180. So 6 minus 2 is 4. 4 times 180 is 720 degrees. So all of my interior angles of a hexagon add up to 720. I'm going to divide that interior angle is 720 divided by 6, and that is going to give me 120 degrees as my interior angle measure. And put a box around that. And remember, our exterior angles create a linear pair. So if I know about 120 of that, then my linear pair supplementary angle is 60. So my exterior angle measure is 60 degrees. All right, found n, yes. I found one interior angle, yes. I found one exterior angle, yes. And I can go on to the next question. Which statement is not true about a regular 16gon? Okay. Well, remember that regular means all sides are congruent, all angles are congruent, and that it is convex. So it is always trying to move outwards. Oops. As opposed to concave, where part of it is pushing towards the center. Okay. That shape would be concave because some of it is trying to get into the center. And convex means everybody is pushing away from the center. All right. So A, the sum of exterior angles is 360. This is true anytime, any place, any regular polygon. Right? It has 16 congruent sides. Well, 16 sides, and all sides are congruent. Therefore, yes, it does have 16 congruent sides. It is a convex polygon. Regular and convex is part of that definition. So I've gone through the part that I know is right. This is the one I got to work on. Okay, I got to test and see if Miss Hart made a mistake and find out, does a 16-sided figure minus 2 times 180 have a sum of interior angles of 2880? And in my calculator, I get 2520. This one is the one that is false. That is not the SOI. Okay? So SOI still 16 minus 2 times 180, and I get 2520 degrees. And that's where I went and made it false. B, false. On number 3, we are told that LMNO is a parallelogram. Okay, LMNO. For parallelograms, opposite sides are congruent. Opposite sides are also parallel. I'm going to mark it that way. Okay. Now then, if Nancy Mary has a side length of x plus 15. I'm going to write that down. And OL has a side length of 3x plus 5. Write that down. I need to find the value of x and Mary Nancy and OL. All right. Well, this almost is just too easy. I've got congruent sides, so their measures are the same. I'm going to do a math sentence that says that they are the same. I'm going to use that equal sign there. Now it's just an algebra equation. I'm going to subtract x from both sides, subtract 5 from both sides, big calculation line. 2x equals 10. Divide both sides by 2, and that gives me x equals 5. Okay, I found x, put a box around it. Now I got to find Nancy Mary. Nancy Mary, I am given that length as x plus 15. Nancy Mary equals x plus 15. I figured out x. I'm going to substitute it back in. And Nancy Mary equals 20 units. Do I have a unit of measure? Nope. I'm going to leave it at 20 units. Nancy Mary, 20 units. Check. Do I really have to do the math for OL? Since Nancy Mary and OL are congruent? I'm going to double check my work just because I'm me. And go OL equals 3x plus 5. And 3 times the x I figured out, plus 5. 15 plus 5 is 20. So 20 units, OL. I have found OL as well. So I'm going to put a funky looking box around that answer. Okay. Number 4, use the diagram below to solve for x. Well, I see a right triangle, and I see 2 side lengths and a missing one. Whenever I see this kind of setup, I automatically think of Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Remember, the legs make that right angle. So I'm going to call this A and this B. And my hypotenuse is always C. Remember, across from my right angle is the hypotenuse. Now I'm just going to fill stuff in. My A side is currently x, and square it. Plus my B side, currently 12, square it. And my C side, which is 13, and square that. I can't take any action on x squared. I'm just going to drop it down. But 12 squared, 144, and 13 squared is 169. So I'm going to subtract 144 from both sides, because I want to isolate that variable, equals 25. Now then, x squared is x times x. I need 2 of the exact same numbers multiplied together to give me 25, or take the square root of both sides, and x is 5. I was asked to solve for x. I have solved for x. And I am done. Flipping the page. Okay. Oh, look. Use the triangle below for problems 5, 6, and 7. Okay, I see a triangle. What is the ratio or the sine of s? Going to my formula sheet. I've got sine, cosine, and tangent right there. So what am I asked for? I'm asked for sine. Sine is opposite over hypotenuse. So sine is opposite over hypotenuse. Okay. Now, I am looking at it from S. S is my angle of interest, or theta. Remember, with trig, it's always from theta's point of view. So from theta's point of view, across the shape is opposite. across from the right angle is always the hypotenuse. It's part of the structure of the triangle. That doesn't change. The part that is either left over or is part of theta but not the hypotenuse is the adjacent. So now I'm going to fill in what I've got. Go ahead and just fill it in here. My opposite is 35. My hypotenuse is 37. That is the ratio or the sine of S. Cool. All right, back to my formula sheet. I need cosine. Cosine is adjacent divided by hypotenuse. Write that down. Adjacent or hypotenuse. And we're still looking at S, so I don't have to deal with theta. Theta still lives there. The adjacent side I already know is 12 because I wrote it down earlier. My hypotenuse doesn't change. 12 over 37 is the cosine of angle S. What is the tangential ratio for tangent Q? Hey, now I gotta erase all this stuff. And I was having such a good time. Where's my big eraser? Well, when theta moves, that means that we have a new point of view. And it's hard to not find her eraser. Because that would be far too... Oh, didn't find it. Okay, here it is. Oh, gotta undo all of that. Gotta move theta. Alright, let's see. So theta is now my angle of interest, or Q. So from theta's point of view, across the shape is opposite. My hypotenuse doesn't change because it's always a structure part of the triangle, leaving me QR or RQ as my adjacent side. Makes up theta, not the hypotenuse, therefore it's adjacent. So my tangent ratio is opposite over adjacent. How do I know that? Well, I went to my formula sheet and I looked it up. Okay. Opposite 12, adjacent 35, and I'm done. Right? So remember, you got to remember to do everything from theta's point of view as far as opposite and adjacent, but your hypotenuse is part of the structure of that triangle across the shape from the right angle. All right? Don't get those messed up. Okay, number 8. Solve for the missing angle. Okay, so that's theta. So let's see, what have I got? Across from my shape is 9, so that is opposite. Across from my right angle is the hypotenuse, leaving me the adjacent side over here. Let's see, I gotta solve for theta. I have information on opposite. I have information on adjacent. Okay, I have information on opposite, no hypotenuse. I have information on adjacent, no hypotenuse. I have information on opposite and adjacent. I'm going to use tangent. I'll write that down. The tangent of theta, which I don't know, equals that opposite side, or 9, divided by the adjacent side, or 12. Now remember, when you have this ratio filled in and you need to go back for that angle measure, you're going to use that -1 function in your calculator. Right? So, trig button down here by control. You get a selection box, and I'm going over to tan -1, selecting it. I have open parentheses, 9 divided by 12, hitting enter, and I get 36.869. So that 9 is going to make 6 jump up, and so I'm going to be left with 36.87. degrees. And I believe on your final, I asked you to round it to the nearest degree. So 36.87 is about 37 degrees. All right. Oh, so I should probably put this here. Theta equals. And Miss Hart should put a box around it. There we go. Oh, sorry. Okay, next one. Solve for x. X is over here. We got an angle of interest. I'll label it as theta. Across from my right angle is the hypotenuse. Attached to theta, but not the hypotenuse, is adjacent. And across from the angle of interest is the opposite. Okay, so let's see, what have I got? I've got theta. I'm interested in the adjacent, and I have the hypotenuse. So AH, who uses AH? Cosine. Write that down. The cosine of theta, which I can fill in, it is 65 degrees, equals the adjacent, my x, divided by my hypotenuse, or 14. And that is my equation that I got to figure out. And remember, 14 in the denominator, x is being divided by 14. In order to isolate that variable, I have to undo division. The opposite of division is multiplication. So I'm going to multiply both sides by 14 and get 14 times the cosine of 65 degrees equals x. X is by itself. Woohoo! I'm asked to solve for x. I'm almost done. So I'm going to put this in my calculator exactly as I see it. Okay? 14 times trig button cosine, select 65 degrees, hit enter, and I get 5.912. Whoops, 5.92. There we go. 5.92 equals my x. Oh, look at that, guys. We actually have a unit of measure on this one. And Ms. Hart forgot to leave a little space for that unit of measure in meters. Equals x. Oh, good deal. We are done with number 9. Solve for x, got x, all good. Number 10. I am asked to get the measure of angle ABC from A through B to C. From A through B to C. That's what I got to figure out. How am I going to do that? Well, first thing I need to write down is that a circle is 360 degrees anytime, any place, any circle. From A through B to C to E and back to A, 360 degrees. Don't care how big or small that circle is. Okay? So if I walk from A to B and then B to C, and I was supposed to be counting my steps and I forgot, oh, bad Miss Hart. Let me do better. From C to E, I counted 85 steps. From E to A, I counted 80 steps. So I actually counted 165 degrees or steps. And I know that I had to walk 360 of them. So I'm going to take the difference. Okay, so minus 165 is going to give me 195. And that is the measure of angle AB, or measure of arc ABC. Cool? All right. Let's go to the next page. Number 11. Oh, this is that ice cream cone theorem, right? Nom, 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 nom. Getting hungry. It's after school. I would like a snack. And here I am told that AB and AC are tangent to circle P. Okay? They want me to find AB. AB. Here is my target. Well, that ice cream cone theorem of two tangents on a circle meeting at an exterior point creates same z's, congruent pieces. Okay? So I'm going to write BA is congruent to CA, and now I'm going to fill it in. And look at that, it's already even marked that those are congruent. So BA is given to me as 8y plus 4. Algebra version of congruent is equal. CA, 12y. That's just an algebra problem. I'm going to subtract 8y from both sides. And that's going to give me 4 equals 4y. Divide both sides by 4. And y equals 1. Hey, I was told to find AB. I found y. Why do I have to do more? It's just not fair. It's just not. But we shall persevere. AB is given to me as 8y plus 4. But I figured out y. So 8 times 1 plus 4 is going to give me 12. I'm going to double check my word. AC is given to me as 12y. And y is 1, so 12 times 1 is 12. And I get the same thing. And I should because they're congruent. So my final answer for the length of AB is going to be 12 units. Let me move that a little bit. Equals, I'll put a little box around it. All right. AB is 12 units. That's what I was asked to find. Found it. Done. Number 12. Find the area of sector POM. From P to O to M, this piece of the circle pi. And I'm asked to leave it in terms of pi. But, you know, guys, on your final, these answers are multiple choice. So you probably shouldn't have too much of a problem, as long as you can do the calculation properly, to be able to choose the right answer. Okay. So what I need to know is what percentage is my piece of the pie compared to the entirety? Well, the way I do that is I take my piece divided by the whole circle, again, 360 degrees, anytime, any place, any circle, and that's going to give me a percentage. And I'm going to multiply that by the area of the circle, which is pi radius, which in this case is 4, squared. Now, I'm going to go back to my calculator and do 45 divided by 360, and I get 1/8 because Ms. Hart can't remember to put in a decimal to get a decimal answer. 0.125 times pi times 16, or times 16 pi, but I want to leave it in terms of pi. So pi needs to be part of my answer. I am not going to multiply out pi, but I will take 0.125 and multiply it by 16 and get 2 times pi. Do not have a unit, so units, but it's area, so it has to be squared. Okay? So the area of sector POM in terms of pi is 2 pi units squared. Okay? All right. Number 13. Okay, when we had a test over this, guys, y'all didn't do great on that. Okay? Well, we have a radius from the center to the edge, and it is a perpendicular bisector to the chord ZY. Okay? Perpendicular makes a right angle. bisector, cut in half, creating samesies on each side. Okay? But that doesn't give me a shape that I can work with. Okay? I'm going to draw in a radius. From the center to the edge is my radius. Okay? From the center to this edge is 2 plus 1.5. And all radii are the same length because it doesn't matter from the center to the edge. All of the radii are exactly the same. They're all congruent. So now I have a right triangle. I'm going to pull it out and make it a little bigger. Okay. And my radius here is 3.5. My space here is 1.5. And I want to know what this side is. I'm going to mark it in my pink pen. Okay, because if I can find this side, I know that it matches this side. And then I can walk all the way across and know how far I have to go. So this is the side I want. I'm going to call it X. If I mark my right angle, I'm good to go. I have 3 sides of a right triangle, one of which is missing. Write the PFAC, okay? A squared plus B squared equals C squared. I'm going to go with this being my A side, so X squared, plus my B side, 1.5 squared, equals my C side, my hypotenuse, 3.5 squared. So X squared plus, let's see, what is 1.5 squared? 1.5 times 1.5 gives me 2.25. And 3.5 times 3.5 gives me 12.25. So I'm going to subtract 2.25 from both sides, leaving me X squared equals 10. I still got to take the square root. Okay. So the square root of X squared is X, and the square root of 10, guys, is the square root of 10. This breaks down into 5 times 2. Those are prime. There's nothing to get out of the doghouse. Okay? So I have an X equals the square root of 10. I'm going to fill that back in here. And put that back over here. And honor the same Z's. So if I walk from Z to Y, I am going 2 times the square root of 10. Okay? So my final answer for ZY is 2 times the square root of 10. Units, it is a distance, so it does not get squared or anything. Now then, some of you guys answered that you are going to put 20 under the square root. Well, let's see what that does. Okay, so I'm going to control square root 20, and I get a decimal 4.47214. And I am going to go 2 times the square root of 10 and get 6.32456. Okay? Those are not the same number. Okay? Those are not equivalents. Those are not equal. All right? But, hey, let's try it this way. How about we do the square root of 10 and then plus the square root of 10. Oh, see? I got the same answer as 2 times the square root of 10. Or if I walk square root of 10 take a break, walk another square root of 10. That's the distance I've walked. Okay? All right. 14. Write the standard form of the equation of the circle with a radius of 6 and a center at -3, 0. Remember, guys, that's H and K when we're talking about circles. Okay? So I'm just going to fill it in. I have x minus h, -3, all of that squared, plus y minus 0, all of that squared, equals radius squared, radius is 6, square it. I'm going to do a little cleanup and get x plus 3, all of that squared, because a negative and a negative turn positive, y minus 0, I'm going to not write in the 0, it just clutters things up, still squared, equals 6 squared, or 36. That is my final answer for the standard form of the equation of that circle. 15. We're almost done. We're almost done. We're almost done with, this one. Given the diagram below, find the measure of angle BAC. BAC. So this angle. Oh, Miss Hart, I don't remember the rules for that. That's okay. It's on our formula sheet. We can look it up. This angle is on the circle. Okay? So I'm going to write down arc divided by 2. And I'm going to fill it in. This angle opens up to a 60-degree arc. Fill that in. Divide it by 2. 60 divided by 2 is 30 degrees. I have found the measure of angle BAC. All right, the last one for this part of the video, number 16. Okay, given the figure below, what is the measure, of angle AOB? AOB, this angle. Well, this guy is not center because center would be here. It's not on the circle because we had on the circle. It's inside the circle, yes, because definitely not outside the circle. All right, so I'm going with in. I shouldn't write on that. It is class set. But I am going to write it down. Inside the circle is arc plus arc divided by 2. Well, this is the angle opening up to this arc. Where am I supposed to get the other arc? From the vertical angle and what it opens up to. So guys, if you're given some kind of measures over here, ignore them. They aren't helping you. You want your angle of interest and its vertical and the arcs that they open up to. So my inside angle is going to be 57 plus 35 divided by 2. And 57 plus 35, 92, divided by 2 is 46. So 92 divided by 2, the angle X is 46 degrees. I was asked to find the measure. I have found the measure. Which makes sense because if I was asked here to find y, well, they're vertical angles and vertical angles are congruent. So I would be taking 35 plus 57 and dividing it by 2. It's kind of the same thing. Again, it makes sense because these are vertical angles and congruent. So I will see you guys next time when we finish up this review on the video. Good luck on the final.